Okay, so we just looked at the groups, and we saw that you had S&P blocks. So the periodic table is divided also by the divisions of S&P blocks, just like we saw. So in your notes, you would say the representative elements, those are 1, 2, 3 through 18. Those are the S&P blocks. And then you have the transition metals, which are the D blocks. I don't like really making you guys go that far, but know that the D blocks is in the middle for the transition. And then the inner transition metals, that is the F block. That is the lanthanoids and the actinoids, or that series. So looking at these, we have some phases going on. And as you can see, you have right here, you've got the red letters all here. These are all gases, where the blue letters are liquids. So bromine and mercury. Those are the different phases. So everything else is metals, except for hydrogen and this section. These are all gases. And then you only have two liquids, bromine and mercury. And then you have the diatomic elements. So I've mentioned this before. It's called Brinkelhoff. That is, or the Super 7, NOFC, CLBR, and I, sorry, with H. BR, Bring, I, N, Col, CL, Hoff, HOF, Brinkelhoff. So you could either remember it as the Super 7, where there's the 7 here with your extra guy over here, or Brinkelhoff. All right, so with this, the periodic table actually has trends that go through it. The predictable way the properties of elements change as you move through the table. So properties that we're going to look at that have trends are the atomic radius, the ionization energy, the electronegativity, and the metallic characteristics. And so the atomic radius. So this is measured from the nucleus to the outermost electron, that valence shell. So this distance, that's going to be the atomic radius. It is measured in PM or picometers. And the factors that affect this are the pull on from the nucleus, that's like how many protons, how much pull there's going to be, and the number of shells that are occupied. The closer it is, the smaller it's going to be. The farther away, the farther it's going to be. Okay, so across the period, across the top, the atomic radius decreases. So it gets smaller because you have more and more protons in it. So a bigger nucleus, more protons means it can suck in more. But as you go down, because you gain energy levels, the atomic radius is going to increase. So it gets smaller as it goes across, bigger as it goes down. So both lithium and fluorine have electrons in the first and second shell. So there's two shells, right? But there's only 3 on the inside. So it's a little bit bigger. Whereas there's 9 here, so it pulls in more. It makes it smaller. Fluorine is smaller because it's got 9 positives, 9 protons in the nucleus. So there's a 9+ nuclear charge that pulls the electrons in closer, and a 3+ nucleus charge, meaning it lost 3 electrons. So down a group, it gets bigger and bigger and bigger. I know they're not exactly to size, but this is the best I could do. You have 2 shells right here, and then you have the third one. So it gets bigger as it goes down. Moving from lithium to sodium, group 1, sodium has 1 more occupied energy level, thus being bigger. Okay, so when I remove an electron, you have this thing called first ionization energy. So looking from sodium to a plus sodium, a cation sodium, which loses an electron. The energy required to remove the most loosely held electron, a valence electron, from the atom, and this is given in kilojoules per mole. No, you don't have to figure it out because it is given to you, which I'll get to in a second. So then we have the ionization energy. So the atomic radius, as it goes across, it gets smaller because there's more protons. As you go down, it gets bigger because of the shells. You get more shells. Now with ionization energy, remember this ionization energy is the energy required to remove those in that valence shell. Remember, you got 1 and 2 over here, so that's going to be pretty easy. And then as you go across, it's going to get harder and harder and harder. So as you go across, because you have more electrons, it takes more energy, the ionization energy is going to increase to get rid of, to lose those elements, or the electrons. As you go down, it also decreases because as you get farther and farther away from the nucleus, you have less of a hold on it, so you need less energy to get rid of those electrons. So across a period, ionization energy increases. So you've got 520 here, 900 here, and then it slopes down a little bit, goes to 801, then the 1086, 1402, 1314, 1681, and then 2081 picometers. More protons in the nucleus create a greater pull, making it more difficult to remove an electron. So it wants to stay on the inside, so it's a lot harder to lose the electrons. And then there are dips, just like you saw right here. There's a dip with boron. So lithium, it increases, boron goes a little bit down. It increases, it goes down a little bit. It increases again. The dips are boron and oxygen, because the p electron is being removed for B, and because its paired electron is being removed. That's going to take, because it's removed, it's by itself, it's not as hard to get rid of. So down a group, going down, you can see the numbers, 520, 496, 419, 403, 376. As it goes down, the electron is farther from the nucleus, which means it's going to be easier to remove. It's not going to be, there's not as much pull. All right, so reason 2. The inner electrons shield the outer electrons from the full effects of the nucleus, diminishing its pull, the pull on it. So the more you have inside, the less pull it's going to have on the outside, the more shells you have. Okay, so so we did atomic radius, the ionization energy. Now we're going to look at the electronegativity. The pull an atom has on a shared pair of electrons, 2 together. The values are based on an assigned value of 4 for fluorine, the most electronegative element. So across the period, electronegativity increases. Because of increasing nuclear charge produces a stronger attraction for the electrons. As you go down, it decreases because the increasing number of occupied energy level puts the outer electrons farther away from the nucleus. So that pull is weaker. Talked about that with the ionization energy. All right, so you're going to have a worksheet with the periodic summary. I'm going to have you do a mini lab with graphing the ionic radius versus the atomic radius. Besides that, if you have any questions, please don't hesitate to ask, and I hope you guys have a great day.